Welcome to Algebra 2, Unit 3, Section 5, Solving Quadratics by Graphing. I can graph quadratics in standard and vertex form. Alright, so today we're going to talk a little bit that if you go on Google and you type in what are the three ways to solve quadratic equations, well, they're going to give you the three ways, right? And one is factoring. The next one is completing the square, or what we call the square root method. And then the quadratic formula. But today I'm going to show you a method that uses graphing. We're going to use technology to help us solve a quadratic equation. Okay? So what does it mean to solve a quadratic equation? It means we find the x-intercepts of a graph or a function. Okay? So in this case, if we were to use the graph, we would find that the x-intercepts are negative 2 and 3. Alright, so when solving and equations, we're looking for the roots of the x-intercepts. A quadratic function can have one solution, two solutions, or no solutions. And the number of solutions is equivalent to the number of x-intercepts the graph has. So we're going to take a look at these scenarios here. So I have three graphs. So our first graph crosses the x-axis here at positive 3 and positive 4. So we have two solutions here. Our second graph touches right here at the vertex. So this is a one solution quadratic. This final equation or function graph doesn't touch the x-axis. Therefore, there are zero solutions for that quadratic. Okay, so in going through what we've been doing so far, let's go through this process. So we're given this example, y equals x squared minus 2x minus 3. So what's the direction of this function? Well, it's going to open up because the coefficient of x squared, or a in this case, is positive. So this is going to open up. Now, if you remember, axis of symmetry, the formula is equal to x is equal to negative b over 2a. Well, in this case, this would be negative 2 over 2 times 1, which is double negatives makes positive, 2 over 2, so that's going to equal 1. So our axis of symmetry is going to be just like this here. Okay, and let's put a little dotted line right down the middle here. So there's our axis of symmetry. Okay, now since we know 1 is the x value of our vertex, we plug that in, right, for the vertex. So what we're going to do here is say y is equal to 1 squared minus 2 times 1 minus 3. 1 squared is 1, minus 2 minus 3. So 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So our vertex is at 1, negative 4. Now, our max or min, well, since this is opening up, we're going to have a minimum here. The y-intercept is going to be negative 3. So we can go ahead and start plotting some points here. First, our vertex, 1, negative 4. So I'm going to go down here to 1 and go down 4. 1, 2, 3, 4, and I'm going to put a dot right there. And next I'm going to, I know this is the minimum. My y-intercept is negative 3, so it's going to be right here. And so I know my vertex is out here. This is a quadratic, so it has that same pattern that we go up 1 over 1, right? Or over 1 up 1. That's how we would do this. Over 2 up 4. So I'm going to have a x-intercept right here, and I'm going to have another one mirrored right here. And if I go over by 3, there's up 4, and then 1, 2, 3, 4, and then here's number 5. That's going to go up by 9. Alright, so I'm just going to put some arrows here, arrowhead, and I'm just going to kind of come down and sketch this the best I can. And there's my sketch, okay? So now we can say, okay, what is the domain? Well, the domain is all real numbers. My range, I start at negative 4, and then I go up to infinity. Or we can write this as y is greater than or equal to negative 4. My solutions, these are my solutions right here. So my solutions are negative 1 and 3. Okay. This function, f of x equals negative x squared plus 6x minus 9. So with the same process we go through. How does this one open? This one opens down because this coefficient here is negative 1. My axis of symmetry is negative b over 2a, right? That tells me that the x value for the axis of symmetry and my x value for my vertex. So, negative b, so this would be negative 6 over 2 times negative 1, which is 6 divided by positive 2, right? This is going to be double negative here, negative 2 on the bottom. So that becomes positive 2, and 6 over 2 is 3. So my axis of symmetry is going to be at x equal to 3. Okay. Now my vertex, I plug in 3. So to find that, I've got y is equal to negative 3 squared plus 6 times 3 minus 9. So 3 squared is 9, and make that minus 9 plus 18 minus 9. Well, negative 9 plus 18 is 9. 9 minus 9 is y equal to 0. So my vertex, and I'll put that over here, is at 3, 0. So I'm going to come over here and go over 1, 2, 3, and 0. Is this a max or a minimum? Well, this is a maximum, right? Our y-intercept. Well, in this case, our y-intercept, whoop, I accidentally slid this down. Our y-intercept is -9, so I'm just going to come here and go down 1, 2, 3, 4, 5, 6, 7, 8, and 9 and put a dot right there. And I know because this is a quadratic, I can mirror this over the symmetric, the line of symmetry. So 1, 2, 3, 4, 5, 6 over, and I'm going to put that dot there. Okay, so my y-intercept is -9. So we're going to go ahead and graph this now. So again, keeping in mind that this is a quadratic, so one right, one left, down one, one right, down one in this case. 2 to the left, I'm going to go down 4 from my vertex. 1, 2, 3, 4. And the same over here. So here's our sketch. Okay, so that is the graph of our function. So now our domain, always in quadratics, is all real numbers. The range, we're going from 0, excuse me, not from 0. We're coming up from -infinity to 0, or you can say y is less than or equal to 0. And our solutions, we only have one solution here. So our only solution here is 3. Alright, so here's our final problem. F of x equals x squared plus 4x plus 5. So the first thing we're going to figure out is, does it open up or down? Well, this is a positive coefficient of x squared, so it's going to open up. Our axis of symmetry, we're going to plug in negative b over 2a. So this becomes negative 4 over 2 times 1, which is negative 4 over 2, which is negative 2. So our axis of symmetry here, gotta fix this here, alright, it'll be negative 2. And you don't necessarily have to put this on your graph. I just do it because I find it, when I graph by hand, to be easier to draw points of reference then. I plug my points in actually. So I know my vertex is going to be on this line, so we're going to plug in negative 2 into our function, right? So f of negative 2 here is equal to negative 2 squared plus 4 times negative 2 plus 5. Well, negative 2 squared is 4. Excuse me there with that. Oh boy. Here we go. 5 equals negative 2 squared is 4 minus 8 plus 5. So we have figured out here that this is 4 minus 8 is negative 4 plus 5 is 1. So this is equal to 1. So my vertex is at negative 2, 1. And this is going to be a minimum. And my y-intercept is the value of c, which is 5. So let's go ahead and start plotting our points. Negative 2, positive 1, that's right here. We can go up to 5. 1, 2, 3, 4, 5 over here, and we can mirror that across this, right? And the next one's going to be up here. So, and here. And I find this way easier to draw on the paper than I do on this device that I use to make these videos. Okay, our domain. Here we go. The domain, as always, is all real numbers. The lowest value here is at +1, so the range is from 1 to infinity, or y greater than or equal to 1. And the solutions, empty set. None. No solutions. There's nothing that touches the x-axis here. Alright, so this is the lesson for Unit 3, Section 5. Have a great day. Peace.